Hello, it's Friday and let's get straight into things. I looked at the internet last night and I saw, 34 days left till the exam. So that's quite exciting for me and really shut for you. But in any case, we're doing 2017 question 1 quickly. I put in here a screen grab of a previous video I did, which was 2018's paper, just to show you that these things really follow kind of the same patterns. And both these questions are 23 marks. So if you can get it right, good stuff. Okay, so first thing we have to find, we have to solve x. What I put in there already is the factors of 14, which is what you require, right? So these factors of 14. And let's see if we can solve this. I'm going to quickly do this. So same old story. Both those are x's. We need to get to 9. So it seems that if I sum 7 and 2, I can get to 9. So let's do that. And it's plus 14 and plus 9, so both of those are plus. So the solution here is x equals minus 7 or x equals minus 2. Cool. 3 marks, easy. The next question, let me just see what I did here. Oh, I made a plot for you of the function so that you can see, and I also indicated the roots over there. So the one is at minus 2 and the other one is minus 7, just for interest's sake, right? I'm going to cough now. So that is the first question for 3 marks. Then, in the second question, we're given this function over here. Again, we have to find the roots or solve x. And already when we hear, do it to round the x values to 2 decimal places, I know probably I'm going to have to use the ABC formula, right? Importantly, this thing is given in the exam, so you don't have to learn it off by heart. All you need to know is that the value of b equals 9, and the value of c in this example equals minus 3, and the value of a in this example equals 4. Okay. If you plug all of these values into that equation, remember, it's a plus or minus, so you get 2 solutions. And what I get is x equals minus 0.29 or x equals minus, well, that's plus 0.29, I think, and that's minus 2.54. You can go and double check. The only thing that's important, and this is the clue over here, is that you're going to use the ABC formula, because there's no factors of 3, which is 3 and 1, that's going to give you something remotely close to 9. And you're also stuck with this 4 in front here, which makes it even more complex. So it'll be easy just to apply the ABC formula, and you just got to get the values of A, B, and C correct. Okay? Next. For 4 marks, you have to solve that equation over there. It's pretty easy, but you've got to keep the exponential rules. You've got to adhere to exponential rules. Okay? I'm going to do this step by step, that I don't lose anyone. So if I'm sticking to this left-hand side, this x squared minus 5 to the square root equals x squared minus 5 to the power of a half. Okay, to the power of a half. Okay, so that root written differently is to the power of a half, or to the exponent of a half. And the same story on the right-hand side, right? The right side. We've got 2 over there, and x squared. So that equals 2 times x to the power of a half. Okay, we need to solve x, so we need to get rid, and I hope you agree with me, we have to get rid of these halves over here on both sides because they're really complex. So let's do that. Well, I've got x squared minus 5 to the power of a half over here. And that equals 2x to the power of a half. While applying the exponent rules, I have to multiply this power by 2. What I do on the left-hand side, I also have to do on the right-hand side. So I multiply it by 2. These cancel out, therefore. Okay. But what did I do here that's incorrect? What you never should do? Well, it's multiplied to the power of 2. That's fine. But it's this entire thing on the right-hand side, right? Okay. So if I zoom in there, I have to apply that to the power of 2 to this half, but to this 1 that's written here as well. Okay. So it has to go to both these powers. Okay. After some simplification, I get x squared minus 5. That's fine because that was to the power of 2 of this entire bracket. And on the right hand side here, I get 4x. Okay, what I'm going to do now is going to take over that 4x to the left hand side to get a homogeneous equation. So I've got x squared minus 4x minus 5. That equals 0. Well, the factors of 5 is 5 and 1. And if I summate these in a way, I can get to 4. This seems fine to solve as is. And I get, again, just a normal factorization xx. And we said the factors of 5 is 5 and 1. I get a minus 5. Okay, so one of these has to be positive and one of these negative. But I know I have minus 4, so this minus has to be at the largest numerical value. What do I mean by that? Well, if I go and check myself here, and I multiply these with one another, these with one another, what I'll find is x squared. I'll find minus 5x, but for this term over here, I'll find plus x, and then I'll find minus 5 again. Okay, and so by placing this minus at the largest numerical value, I can make sure that when I simplify this, I do get minus 4x. Okay, so solution to the answer to the question therefore is x equals minus 1 or x equals 5. Cool. Done. Another 4 marks. Really easy. But the only thing you have to know here is to apply the square to this entire bracket. And you see I almost made a mistake and forgot to do that. So shows you how easy that can happen. Okay, number 1.2 is just solving simultaneous equations. I hope by now you know how to do that. Also easy marks because it's 6 marks. And your only homework would be probably not to make a mistake. What I would do, my strategy for this example would be, this is by far the simplest equation. Okay, so I would write, and I'm going to call this 1. And this guy over here I'll call 2. So from 1, I will say that y equals 3x minus 4. Okay, so I take that y over there and I bring this x over here. So I get y equals 3x minus 4. And that I call, well, I can keep that as 1. And so I'll say 1 into 2. Okay, so I'll get 2. I'll get x squared plus 2x. Okay, and now I have to substitute that y into there, so that will be 3x minus 4. Okay, minus, and it will be y squared, so 3x minus 4 squared, that equals minus 2. Okay, you're going to simplify this guy over here. Again, you're going to get a second root polynomial, or second order polynomial, which is nothing else than a parabola. After some simplification, I get something like this, minus 2x squared plus 16x minus 14 equals 0. So you can go and check yourself. And if you solve this, you'll get x, write that over there, x minus 7 and x minus 1. Okay. Is there a mistake somewhere? No, that's fine. Cool. So you'll get x equals either 7 or x equals 1. And then you'll plug that back into equation 1. So you'll get y equals 3 times 7 minus 4. So the corresponding y over here would be y equals 17, I guess. And y equals 3 times 1 minus 4. So that is minus 1. Cool. So those are the two values. You solve the simultaneous equations. You get two values for x because you have the second order polynomial here. So in essence, you have a parabola. Two values of x, and therefore you'll have to have two values of y. Okay, 6 marks. No problems. It's just a question of not making any mistakes whilst you're working. Okie dokie. Now, in the next example, we're given a function. By inspection, we already know that this is a parabola. Okay. And we have to calculate values for x for function values positive. Okay. So, hypothetically speaking, and I don't know exactly the details of this, but this is my x-axis. This is my fx. Okay. I have some kind of function. We can talk about the roots and all of these things at a later point. But, and I don't know what it is, right? In essence, I'm looking for these x values. Or an x value, where this function value in total is positive. So all of these areas are cancelled out. Okay. In the previous slides there was, and in the 2018 paper there's exactly an example like this. This is just a special case. And why? Because I'm going to solve the roots and then we're going to see why I'm saying it's a special case. So, and by the way, just to refresh your memory, the roots are these things, right? And this, again, is just a generic representation of a parabola. And now we're going to calculate exactly what it looks like to a certain extent. So, we've got x squared plus 8x plus 16. We're going to set that equal to 0. Because we want to find these root values. We have to solve x. Okay, I get two brackets over there because I'm factorizing it. And again, I have possible multiples of 16. So, or factors of 16. So it would be 16 times 1. Well, I have to get 8, so that's not an option. I can get 8 times 2. That's not an option either because I have to get 8. But I also get 4 times 4. And that seems like a viable solution. And here comes in the special case, right? So I have plus and plus. So this I have to plus. So both of these have to be plus. Now I find that the values of x, therefore, is only x equals minus 4. Okay. What that therefore means is that this parabola, more specifically, just do that, looks something like this. have a special parabola here. And it only touches the x-axis at one point, one single point, and that's the coordinate, well, -4, 0. Okay? So, let me see, what can I say then further? It has to be larger than 0. So it's not including that point, right? Because at that point, the function value is 0. That's what we used to compute it here. So, therefore, the values for x is, well, for 4, smaller than -4, okay, and for x, larger than -4, but not, and this notation here means that it's not including -4. That's super important because we know that the function value at that point is 0. Okay? So it's the same as a 2018 paper, it's just a special case. Why is it a special case? Because it's only got one root. And therefore, you know, for all values except this one to the left is smaller than -4, and to the right larger than -4. All these function values, see, all of them are positive, right? Okay, that's a solution. Cool. Then question number 3, I think. Okay, so we've solved 3.1. We've done that. And now, for a special case, what we have to find, and I'm going to draw this again. So I have a function that just touches this point over here, and that's -4, 0. Okay. I have some kind of coordinate here that I'm not too sure of at the moment. I can easily calculate that because I know the value here is x equals 0. Okay. So let me just do that all. That's fx, that's x. Cool. So that point there is known. That point there is unknown, but I can easily calculate it. So what's the question then? The question is, well, for which values of this p will this function have 2 unequal roots, right? Okay, so what this in essence is asking us is here with fx equals to 0, this function has equal roots, right? Because and also negative. Okay, but they're equal because both of them are -4. Okay, so I know that p can't be 0. But I'm going to draw a line in here. This is a very small little graph to show something so important. But okay, so that's the line p equals 0. But if I make this line p equals something larger than 0, okay, then I do get 2 negative roots, but they're not equal, okay? Then, if I take this, so line, and this is another scenario for the line for y equals p, but I make this p value large, then I'll have 2 roots, but the one will be, and they'll be different, but the one will be negative and another one would be positive, right? So somewhere here, and what I propose to you right there, is a point, is a cutoff point, where the values are still negative, but the roots are still negative, but not equal. Okay, so, oh, this is so terrible because I drew it in such a small space. But here, in this little region over here, not 0, but somewhere in between here, those are the p-values. Okay, and I hope you can see that in. So, I need to calculate the value, therefore, of this point over here. That's easy because I know x is 0 at that point. So, let's calculate the function value at the point x0. I get 0 squared plus 8 times 0 plus 16. Okay, so I know that the coordinate of this point over here is 0, 16. Okay, so what's the solution now? P can't be 0, but it has to be larger than 0. If it's 0, it has equal roots. P can't be larger than 16, okay? But it can't be 16 either, because then that root value is exactly 0, and it has to be negative. So it has to be values smaller than 16. Okay? And that's the answer to the solution. I do apologize for this terrible small little graph over here, but the idea is that for p-values in this y range, right? Those are the ones you want. Not including 0 and not including 16, but in between that. Anything larger will give you 2 roots, but 1 positive and 1 negative, and they explicitly ask for 2 negative ones. Okay, so that was that. And I think that is question number 1.